What's up guys, welcome to another tutorial. Today I'm going to show you how to calculate distance and bearing inside Excel using known coordinates. So we're going to calculate the distance and bearing between 2 points. So if I open up this Excel sheet, I've created this one from scratch, and what we're going to do, I've just typed in the coordinates of all these stations. So these are the coordinates. So we're going to see how to find distances in between the various stations on this survey plan, on this piece of land. So what we're going to do, we are going to move from the first station. I've chosen this one to be the first station, L13, and we're going to move clockwise all round, and then go back to the same station, L13. So I've just typed in all the coordinates, and I'll provide you all this data so that if you want to follow along this tutorial, you can do so. So I'm going to copy. So you can see that we have different columns. We have the point ID, we have the station, northing, easting, the line, change in northing, change in easting, then distance, bearing in decimal, and then the bearing. We're going to convert this bearing in decimal to the actual bearing. So we are going to start with the first column, and then second, third. So we have station, northing, and easting. These ones I have already them in a separate sheet. I'm going to copy all of this data. Right click and then copy. You're going to copy, and this like so. So we have the values, we have the station, the corresponding northing and easting values of these stations. So you realize that the last station is empty. Is that because that this one belongs to the first station, because we said we are moving all around and then coming back to the same station. So that's why it's empty, and we're going to copy everything in the first row. Sorry about that. So let me copy that and then paste the values like so. And then the third, the next column is about line. We are going to indicate the lines. For example, we are moving from L13 to TL3, so that's a line. TL3 to C1, that's a line. C1 to B9, that's a line. So we are going to use a formula to write that for easy verification and visualization. So the formula is, you type in equal sign and then select. So we are saying we're moving, this line is L13 TL3, so we're going to use a formula equals to that cell, and then because we are concatenating means we are joining two texts. You're going to add ampersand, and then double quotes, then space, and add another double quote, ampersand again. That is shift and letter 7 on my keyboard, like so, and then choose that second station and click enter. So just like that, and then we're going to copy the formula all through to the bottom. So place your cursor at the bottom right corner of this cell, and then just drag down like so, and then boom, you have your stations, your lines. Now the next column is about calculating the change in northing and the change in easting. For this one, again, we're going to use a formula. let me just show you what we're talking about. So we're saying, let me increase here the font so that I'm going to just type in the formula. Let's do 26. So we are saying change in nothing is equivalent to change is equal to nothing 2 minus nothing 1, like so. So this is the formula, and the same applies for easting. Copy that, then the same applies for easting. We are saying change in easting is equivalent to change in easting 2. Easting 2 minus change in easting 1. Easting 1. So that to say that delta 1, so delta n, like so, delta n equals to n2 minus n1, and delta e, that is delta easting, equals to easting 2 minus easting 1. As simple as that. Easting 1. So we are going to apply this formula in this Excel sheet. So we are here. We are saying that the nothing, changing in nothing at this particular line is equivalent to nothing of TL3 minus nothing of TL L13. So write a formula equals to nothing of TL3 minus nothing of L13, like that, then click enter. Copy the formula again, use the same tactic, place the cursor and then scroll down, drag down, and we have the changing in nothing for all these stations. The same applies for easting, equals to, we said change in easting is equivalent to easting 2, easting of the second station, minus easting of the first station, that is L13, and enter. Then copy the formula down, just drag down the formula. Now we have changing in nothing and the changing in easting, and the formula for calculating distance is, let me show you how to calculate distance. Now distance is equal to the square root of square root of change in nothing delta n square root plus the square of delta e. So this is the formula which is equivalent to the normal Pythagoras theorem, which is h equals to square root of a squared plus the square of b squared. So h is equals to square root of a squared plus b squared. So the same case applies for finding the distance here. So we are going to apply that. So we are going to write that formula equals to, you type in sqrt like that, and then we're choosing nothing first, and then comma, and then choose the second value, which is change in easting, and then bracket. Oh, sorry about that. So we said, let me repeat that. We said distance is equals to the square root of the square of a plus b, which is change in nothing squared plus change in easting squared. So we are going to write square root, and then in order to write, let me place this side by side so that you can understand what we are talking about. Like that. So the square root of the square of delta n, we've already written this square root sign. This is the square root that covers everything here, and then now we are going to write the square of nothing, change in nothing. So that will be right power. So power, and then we are going to choose nothing, comma, to power 2. So we're going to write to power 2, close bracket. We're going to add to the square of change in easting. So we write again power, the power of change in easting. So select easting, and then we're saying easting to power 2. So easting to power 2, like that, and then close bracket again until you see it turning black. So hit enter, and then copy the same formula down, just double click, and then we're going to we want everything into 2 decimal places. So I'm going to select the whole column, right click, go to format cell, and then numbers. We want to 2 decimal places, so you can change that to 2 decimal places or 3 decimal places as you wish. So now we have the distances. Let's try and check some of these distances inside the survey plan. Now let me resize this. We've said we can check the example here. Let's say from let's take the example of from C15 to C14. So we have that line here, C15 to C14. You can see the distance C15 to C14. Let's check if our calculation is correct. C15, C14. As per our calculation, we have the distance as 144.99, 145.00. So that's okay. That's accurate because we can see that on this coordinates list, someone actually tried to change a few things here and there, especially here in C14. You can see that there was change, and this slight change can cause that minor change in distance. So we have very small discrepancies here, which is very accurate. Or let us just check for another line. Let's check for let's say from C10 to C11. C10 to C11, you can see the distance is 148.57 as per our calculation, and on the survey plan you can see it is 148.57, so which is very accurate, perfect. Now let's move to calculating the bearing in decimals. So in order to calculate the bearing, you also have another formula. So first of all, we're going to calculate the bearing in radian and then convert to degrees. So in order to calculate the bearing in radian, we're going to use a formula, tan 2. Tan is the inverse of tan. So if we open, let me open the Microsoft support. So if you read this description about tan 2 function, it says that it returns the arctangent or the inverse tangent of the specified xy coordinates. So and the last statement says that the angle is given in radians between negative pi to positive pi. So the moment we insert that formula, you only need to mention or specify the change in northing and the change in easting inside that tan. So we are going to write that formula. So write equals to, then tan 2, double click on that and choose. So the first value is the change in northing, select that and type comma, select the second value, change in easting, and then close the bracket and hit enter. Then again you can double click to copy down, but before we proceed, we say that this is now in radian as per the article that we just read from Microsoft. So we want to convert this value to degrees. So because we are dealing with now degrees, as you have seen in this survey plan, everything the bearings are in degrees. So we are going to convert that radian value to degrees, and in order to do that, we are going to use another function called degrees. So just type in degrees in front of the formula that we just used to calculate the bearing in. So degrees, and then make sure that you close that formula properly like that. In order to be sure that you have closed that formula properly, you should be able to see the last bracket in color black. So click enter. Now you can see the bearing is now in decimal degrees. So double click again to copy down the bearings. Now let's again have a look at, or have a preview of that, of our calculations. So if I open up this survey plan of ours, so from, let's say, from B9 to C6, let's have a look at, you can see that from the survey plan it is 58 degrees, something like 30, I guess this is 30 minutes and 0 seconds. And from our calculation, you can see that the integer, the degree is 58. So we are now going to convert these values to decimal, to degrees, or degrees, minutes and seconds. And before we do that, you can see that some values here are negative. So in order to get rid of these negatives, it means that these negatives, it means that these are back bearings. And in order to do to do away with the negatives, we are going to calculate the back bearing, and from my previous video you can realize that what we normally do to get the back bearing is to add 360 to the negative value. Let's say 360 plus, or just 98. Let's say 98 degrees. Sorry, this is negative 98 degrees plus 360, and then you get 262. That's the back bearing of this negative value. So we're going to incorporate that in all this formula, and in order to do that, we're going to use the another formula, another a function that is called modulus function. Let's say modulus function in Excel. So you can also go ahead and read about modulus function, what it does, and how important it is in your calculations. So in order to incorporate modulus function, we're going to add modulus function at the beginning of this formula, and then we're going to get the remainder from 360 degrees and close the bracket. So since we are dealing with bearing that are less than 360, so we are going to do the modulus of this of our calculations to 360 degrees. So if I open, let's open another formula to read about. If you place a cursor on this mode, you can see that it returns the remainder after number is divided by a divisor. So that's it. So copy again these values down. Now you can see that all the negative values have turned to positive. That means that the negative ones were in back bearing, so you convert. So you are getting the back bearing of that line. Now we want now to get the bearing, the proper bearing, degrees, minutes, and seconds. In order to do that, you can see that on this other side we're going to hide this, but this one is going to help me now to find these values in degrees, minutes, and seconds. So in order to get the degrees, we say equals to let's first of all get the degree part. Here is integer. We only want the integer, so we write the formula and then the function. So the function is int. Only want the integer part, the 65, and then select this cell, close, and then enter, and then copy down to that place, to that point, and then so we now have the degrees. We have the degree part, and then we want to get the fractional part of it. We are going to subtract this degree from these bearings in decimals. So just write equals, and then select the cell bearing in decimal minus the degrees, then click enter, and then multiply, copy down the formula. Now that we have these fractional degrees values, these ones are going to help us to convert them into minutes. So in order to get the minutes in decimal, we're going to multiply these fractional degrees by 60. So in order to convert a degree value to minutes, you normally multiply that by 60. So another formula equals to this fractional part. You multiply that by 60 and hit enter, and then you get your values. You get your minutes in decimal. So again here, minutes, we are going to get the integer value of this minutes in decimal, and then subtract again to get the fractional part. So another formula equals to int, the integer. We only want the integer of this value. Close the bracket and then click enter. We now have the minutes value. Now again, to get the fractional part, repeat the same process. Equals to the minutes in decimal, subtract the minutes that we've just calculated, like that, and then double click. So this fractional part again is going to help us calculate the values in seconds. So again, repeat the same process. In order to convert minutes to seconds, you multiply the value by 60. So equals to this fractional part, again you multiply by 60. Click enter, then double click. So for this case, we're going to be a bit different, because we're going to round off to 0 decimal places. So another function called round, and then we are going to round to add a comma, then the value here is we're going to round to 0 decimal places, and then close. Click enter, then double click to copy the formulas. Now we have these 3 important columns. Let me just change the colors to green, like that. These values are very important. Now we are going to we have degrees, we have minutes, we have seconds. So we are going to copy them, write them here in this bearing column. So we are going to use the same formula, the same concatenation formula. So that is equals to degrees, and then ampersand. That ampersand is for joining, and then close, opening quote, double quote, and then we are going to type in, or to type in the degree symbol. So the formula for degree symbol, or the combination key, is Alt, press down Alt, and then type 17. Oh, sorry. Press down Alt, do not release, type 0176 and release. You can see now we have the degree symbol. Let me repeat again. The combination key is you press and hold Alt, and then you type 176. Oh, sorry. Type in 0176. Do not forget 0, the way I did. So Alt 0176 and release Alt. The moment you release Alt, the degree symbol is going to be inserted, and then place Alt, or close the double quote, and then add the ampersand. That is, on my keyboard is Shift and then 7, and then I'm going to add the minute, ampersand again. So minute sign is the single quote. I'm going to type in the opening double quote, type in the single quote, and close the double quote again. So now we have double quote, single quote, double quote, and then ampersand again, and then choose second value, double quote, then another double quote. So inside we are going to have two double quotes and then closing one. So in total we're going to have 4 double quotes in order to create the second symbol. So if you hit so we made a mistake somewhere. So we forgot to add ampersand there. Let's try that. Now we can see now we have the values in 60 degrees. This one is 65 degrees, 9 minutes and 23 seconds. Now let's add some spaces. Let's add something like 4 spaces, 1, 2, 3, 4, and on this again 1, 2, 3, 4, and then hit enter. So we're going to copy down this formula like this, and you can see now we have the values, the bearing in distance, in degrees, minutes and seconds. Let's confirm with at least one line, although there are going to be a slight difference. Let's check the value from this one. They've given a back bearing instead of, now from, let's say from C23 to L21D, C23, where is C23? C23, C23 to C19, C23 to C19. They have given, that one is in, let's choose this one from let's check C10 to C11, C10 to C11, C10 to C11, C10 to C11. From C10 to C11, from this survey plan, it is 58 degrees, 30 minutes and 0 seconds. And according to our calculations, according to our formula, C10 to C11 is 58 degrees, 29 minutes and 60 seconds. So that means if you convert this second to minutes, so you convert this one, it becomes 1 minute. To add to this, it becomes 30 minutes. So it's perfect. So 58, 30 minutes, 0 seconds. So you can see that our calculation is very perfect. So that's the way you can actually calculate the distances and bearings using the Excel sheet. So I'm going to provide you with this all of this data or this Excel sheet, so that if you want to practice or you can follow along this video, you can also do so. So see you in the next tutorial.